Hello students, welcome back to InstaOwl video lecture series for maths. We believe in democratizing education for all. Today, we are going to learn the application of the probability and few exercises based on probability. Come on, let's get started. So let us understand about the playing card. We know that in the deck of 52 cards, in this playing card, we have 52 cards in it. And then there are 4 types of card that is known as suits, okay? Spades, heart, diamond and club. In black we have spade and club. And in red we have heart and diamond. And in each suit we have 13 cards. Means spade has 13, then we have heart 13, diamond also 13 and club also 13. In that 13 we have one ace card, right? Then we have face. These are the face card. We have king in face card and then queen, jack and number card we have 2 to 10. So face card we consider only the card having face in it, means it will be only king, queen and jack. So this is the card, playing card having black. We have spade and club, and then in red we have heart and diamond. So these are the face card, numbers card, and this is ace. Okay, let's see the example of tossing a coin 2 times. So in first coin tossing, we know that we can have head or tail, right? So each probability is 0.5 and 0.5. Why? The total number of outcomes in this event is 2, right, in each event, and then for event getting head is 1. So that is nothing but 0.5. Same for here also, we have 1 upon 2, that's why it is 0.5. So now when we flip the coin 2 times, already we have head and tail, right, in the first flip. Again we flip it. So what we will have is what? See, head, either you may get head, means in the first flip you will get head and second flip head, right? So or head and tail. So in the first flip you may get head or second flip tail and then tail head, right? So you may get tail in the first flip and second flip you can get head and last tail. So we have the case of head, okay, head tail, and then we have tail head and tail. So these are the 4 possible outcomes when we have the second flip. So in its flip, total number of outcomes is 4, and for getting head, okay, it will be 1 upon 4. That is 0.25. Same for here, 1 upon 4, it is 0.25. Here also 1 upon 4 is equal to 0.25. Same here, 1 upon 4 is equal to 0.25. Right? So what is the probability of getting 2 head in flipping coins 2 times? Then it is 1 upon 4. That is 0.25. So this is the example of flipping the coin 2 times. You may get the questions like flipping the coin 3 times also. Okay. So here it is. So what is the probability of getting 2 head? So 2 head we have only 1. So 1 upon 4. Right. So what is the probability of getting at least 1 head? This is very important. At least 1 head means what? Either you may get 1 head or 2 head is also possible. Right. So in the sample space, right, we have head, right, head tail head and tail, right? So N of S means total number of getting the possible outcomes is 4, right? So in this case, question number 2, right? So we have the event is what? Getting the what? At least 1 head. So E will contain what? Head, 2 head is possible. Then we have head tail and then tail head. Okay, so in this case the number of getting this particular event is only 3. So the probability in this case, P of this event E is what? Number of favorable outcomes upon total number of outcomes. Instead of that, we can write it as N of E upon N of S. That's it. N of E we are taking as a number of favorable outcomes to this particular event E. And N of S represent the total number of possible outcomes. So in this case, we have 3 upon 4. So the answer for the second one is 3 upon 4. Right. So the next is, what is the probability of getting exactly one head? Exactly one head means you cannot have both the head together. So this case is gone from this event. So means we will not be considering this two right now. We will be taking only this because it has exactly one head and here also exactly one head. So in this particular case, for the event, let's take it as F. So F we are considering as event of getting one head. So this will contains what? Head tail and tail head. So N of F is equal to 2. So probability of F is equal to N of F upon N of S. That means what? 2 upon 4. That is 1 upon 2. You can write this as 0.5 also, or you can leave as 1 upon 2 also. Choice is yours. So like this, we calculate this question. If 3 coins are tossed simultaneously. So here we have, in one coin we can have only head and tail, right? But if 3 coins are tossed simultaneously, then there will be the possibility of getting head, head, head. So this is for the first coin, okay? This is for the second coin and this is for the third. Okay. So this is first coin, second coin and third coin, right? So in that first event we can get head, 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 right? In all the coin we can get head, head, head. Next we can get head, head, tail. Last coin get tail, right? So then head, tail, head, right? Then tail, head, head, right? Then we can have tail, 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 right? Tail, tail, head, then tail, head, tail, right? Then we have head, tail, tail. So total number of outcomes will be 8, right? 2 into 2 into 2. How to decide it like this? How many possible outcomes will be there? So this is the S. So S contain all of this, right? So since this is a set, it will be separated by commas. Now N of S will be 8, right? Because the total number of possible outcomes is only 8. We can't have more than this, right? The first one is, what is the probability of getting exactly 2 head? So exactly 2 head means this is X not included, right? Exactly 2 head, this is there, this is also there and this is there. We cannot take any other things, right? So the first one, let's write down. E is event of getting exactly 2 heads. Here we have head, head, tail, tail, head, head and head, tail, head. So there are 3 outcomes for this. So probability of this particular event E will be what? N of E upon N of S. So that is 3 upon 8. That's it. Okay, so let's see the next question. Next question we have, what is the probability of getting at least 1 head tail? At least means what? Minimum 1 tail is required. You can have 2 tail also, 3 tail also, right? So let's count from here. First one, we cannot consider it because there is no tail at all, right? The second one has 1 tail, we'll consider this, right? Then this also has 1 tail, again this will also consider. This will also consider, right? This is also considered because it has 3 tail. This is also considered, it has 2, same here also, same here also. So only the things that is not possible is HHH, right? So total there will be what? 7, because we are not considering the first one. So let's write down this. So F is even of getting at least one tail, right? That is nothing but what? S minus, instead of listing everything, we can write it this way also. Now, N of F is what? 7. So, probability of even F is N of F upon N of S, that is 7 upon 8. So, the last question we have, what is the probability of getting 3 head? We know it's 1, right? We can have only one possible outcomes for this. So the event, let's consider as Z. So event of getting 3 heads is what? H. So N of Z is 1. Therefore, probability of the Z is N of Z upon N of S, that is equal to 1 upon 8. Now, look at this. This event F and this event Z are complementary, because in this event, probability of getting 3 hat is not included, and here 3 hat is there. So, we have these two are complementary. Look at this addition also. The addition is 1. So let's recap what we have learned in this video. In this video, we have understood the application of probability by taking the example of the tossing a coin 2 times and 3 times. We have also understood the 52 deck card, right, and the probability rule of finding the even and the complementary event. So I hope you have understood thoroughly the video. Keep watching our InstaOwl video. Thank you.